And welcome to season 34 of Logicast. I'm Carl Robinson, CEO and co-founder of Logicata. And sadly, I'm only joined today by my colleague, John Goodall. How are you doing today, John?
I'm okay. Got some DIY done at the weekend, which made me feel a bit better.
What did you do yourself?
Oh, my outside light was playing up. You turn it on and it would just trip the breaker immediately. So that was about an hour of troubleshooting to work out that it was, as ever, a faulty ground wire.
Earth
It's always,
leakage.
always an earth leakage. Always, always,
Mm.
always earth leakage.
Well, this is thrilling. I'm glad that you had such an exciting weekend. But we're not here to talk about earth leakages and electrical faults in John's home. We are here to talk about AWS news. We did have a guest lined up for today. Sadly, they haven't turned up. So it's just John and myself to talk to you about AWS news.
Oh, I mean, my cat's back there, but I don't think she'll have an opinion.
No, not a valid one anyway. But so if you're new to the podcast, every week I collate a list of AWS news articles, which I share via my weekly AWS Roundup newsletter. And then John and I pick a subset of those articles that we want to talk to you about on the podcast. So we've got a list of articles that we'd like to talk about this week. And the first one is an article on Forbes. And the title is that Amazon has unveiled some new cloud storage offerings at AWS Storage Day. So recently there was a day focusing specifically on storage. And as always, at an AWS event, there's a whole bunch of new stuff. So what exciting new storage? Well, before I ask you that, let's look at those statistics first before we delve into the exciting new storage offerings from AWS. So the article does list a whole bunch of stats. The first one is that Amazon.
Big numbers.
Yeah, I love a big number. So the first one is the Amazon Elastic Block Store (EBS). That's disk drives connected to virtual machines. Transfers more than 13 exabytes of data daily. That's a lot of data. What's an exabyte? That's beyond a petabyte.
It's 1,000 petabytes.
Yeah. So you've got megabytes, kilobytes, megabytes, gigabytes, terabytes, and petabytes. It's
and then exabytes
of data.
Yeah.
I mean, if you
Let's
wanted
not
to
start
store
getting
that
into the difference between like gigabytes and gigabytes and mebibytes and petabytes or whatever it is they call.
That's your metric thousand versus 1024 because you're
Yes.
counting in bits and so on and so forth.
Because when you get to these sorts of scales, 1,000 versus 1,024 makes actually quite a bit of difference. When it's 1 gigabyte, I mean, you say that 30 years ago, I'd have been shot. But, when it's 1,024 megabytes versus 1,000 megabytes, in today's modern world, that doesn't make a huge amount of difference. When you're talking about exabytes, that's, enough to store my entire digital life several times over.
Yeah, and that is every day that EBS volumes are doing that, transferring that amount of data every single day. So that is just eye-watering. And the next one is that in 2023, for the whole year, EBS handled more than 1 trillion IOPS.
100 trillion.
100 trillion IOPS daily. 100 trillion input-output operations per second daily. I mean, that's just unfathomable. How do you, I'd love an analogy like, that's driving to the moon and back several times. I don't have one, sadly, because I haven't thought about it in that way. But these are just crazy numbers.
I mean, it's probably, and I'm making this up on the spot, but it's going to be similar to the amount of water in grams going over something like Niagara. It's just, these numbers are so big that you just can't comprehend them.
Yep, absolutely. Here's another one. Amazon S3 holds over 340 trillion objects, averaging 100 million requests every second. 100 million requests every second. And of course, Amazon are charging for those. No, not very much, but
well, they charge per 1,000, so yeah.
But that's still a lot of chargeable units of stuff going on storage. And what else have we got? S3 request traffic peaks at over 950 terabytes a second.
That's terabits.
Terabits a second globally. But bits, bytes, it's still a lot.
No, that matters because you divide it by 8 because it's 8 bits to a byte. But for some reason, I never understood this, network traffic is measured in bits per second, not bytes per second.
Yeah.
So like your home broadband, for viewers in the UK, I'm going on a tangent, I'm not sorry. Your download speed is in megabits per second. People say, well, what does that even mean? If you have 80 meg broadband megabits, you can download at peak capacity 10 megabytes every second, right? Divided by 8. So 950 terabits a second is still stupid amounts, but it's 8 times less than terabytes a second.
But even if you divide it by 8, it's still a stupid amount. So
it's over 100 terabytes a second. It's just,
yeah. And then the last big stat here is over 2 billion Amazon S3 Glacier restore requests were processed every week in 2022. 2 billion requests. I mean, it's just, these numbers are ridiculous.
That makes me think people are putting more in Glacier than they probably should have done.
Yeah, you say Glacier, I say Glacier. Let's call the whole thing off. No, you said, what did you say? I can't remember how I said it now. I think I tried to pronounce it the American way.
Well, surely
I think I said
American
Glacier.
Way, Glacier.
Glacier, yeah.
Ugh, I feel dirty.
Anyway, before we offend any of our listeners, let's move swiftly on and talk about some of the new stuff. So, John, tell us a bit about some of the new stuff. What's piqued your interest here?
Well, they talk about FSX for Lustra, and I don't really want to talk about that because it's kind of not my area, but it's designed to, eliminate bottlenecks and optimize resources, and it's got some AI and ML sprinkled in just to be trendy. So that's a thing. It's kind of useful for things like financial modeling, media processing, basically where you need to move lots of data very rapidly, very consistently. So that's kind of a thing. It's integrating with S3 Object Store, which is cool, so that you don't have to. The way I'm reading this is it's POSIX compliant, which I'm not going to go into detail, but that's useful for certain workloads. And it means you're not having to keep everything on the more expensive storage tier. You can keep it in S3, which is cheaper, and just kind of synchronize them when you need them, which is great. File release, I'm not going to talk about because that's basically what I've just said. It's, backing things to S3, so you're not having everything on the more expensive disk. And then you can do things like lazy loading, so you can read the file as if it was there, and if it wasn't there, it will just be got back from S3 when you need it, and things like write through, because you write to the file system and it syncs back to S3 later. So these are pretty common caching, but it's nice that it supports it. For a more concrete example, if you use OneDrive and you don't store all your files on disk all at the same time and you get it when you need it, that's lazy loading. You've asked for it and then it goes and gets it. That's lazy loading. What's more interesting for me is the logical air-gapped vault in AWS Backup. So AWS Backup is something that we use to help our customers with their backup requirements so that they can hit their RTO and RPO requirements, which is recovery time and point objectives for those that are unfamiliar. And if you're unfamiliar, A, get familiar, and B, I envy you because you haven't had to care.
You've never needed to recover.
No, or think about recovery or worry about DR and all that jazz.
Yeah.
A logically air-gapped file. So air-gapping in tech means that your device is not physically connected to anything else. So it would be the equivalent of taking an external drive, unplugging it, putting it in the safe. That is air-gapped. There's no way of getting to it because it's surrounded by air. There are hacks that involve doing really cool things with like speakers and infrared on air-gapped PCs, but let's not go into that because you can get really scary. But a logically air-gapped vault is it's kind of saying it's air-gapped, really air-gapped, but it's acting like there's no way of getting to it until you go and tell it to plug back in, which is kind of handy. It stores the data as immutable backup copies, so you can't ever change them, which is kind of how they say it's logically gapped because you can't ever overwrite it, which is sort of useful. And then there's a couple of other bits in there as well about multi-cloud operations for data sync and yada, 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 but I don't really want to go into those. Like I say, AWS Backups, logical air gapping is handy if you have a requirement to be more paranoid about your data than most people. And in the world of ransomware, that's kind of handy.
Cool. All right, well, we've talked enough about storage, I think. So let's move on to the next article in our list this week, which is an article from our friends over at InfoQ about AWS introducing dedicated local zones for sovereignty requirements. And when I spoke about this on the News Roundup video last week, I described it as outposts on steroids, I think is how I'm reading it. Big outposts. If you need to run your own local AWS resources on equipment in your data centers at scale, then it seems that this is the answer for if you're large, if you're a country, perhaps, or a government, maybe a government department. But yeah, what are your thoughts on this one?
Well, your description's not far off, but it's not quite right, because a dedicated local zone is not running in your data center, right? An outpost is running in your data center, running cloud workloads where you have it. A dedicated local zone is a local zone that is only accessible to a singular AWS customer, but it's still run by AWS in AWS's buildings using AWS's staff on their hardware. So that's kind of the delineation. But apart from that, you're not far off. As you say,
But it does say in a customer specified location or data center. So,
yeah, but it's saying, it also says AWS personnel, so it's AWS running
yeah,
it.
yeah,
So
yeah,
it'll
yeah,
be,
for sure, yeah.
it'll be, you know, I want my dedicated local zone in London, in Stockholm, in wherever. And this is kind of handy, because if you have data sovereignty requirements, and as it currently stands, outside of contractual things, there's only a couple of countries that have this legislatively, being Russia and China, I think. I'm sure North Korea probably does, but we never hear from them, so I don't care. But this is definitely going to be more of a thing as the world kind of wakes up to the idea that people like the NSA can just go, it's owned by an American company, therefore I want to see it. Which is just like, that makes people really very uncomfortable, because then all of a sudden you're subject to laws and restrictions from regions that you're not in, which is, I don't know, it just feels a bit wrong. But this is kind of a clawback against that. It's saying, if you have the money to run your own private cloud, which is basically what it is, it's private public, kind of private cloud run by AWS for you, then they'll do that, which is, I mean, it's interesting. Simultaneously, I'd love and hate to see the bill. Like, I'd love to see it, but I wouldn't want to pay it.
Yeah, I don't think the pricing is, it's price on application, I think, which is unusual for AWS, but yeah, it means it's going to be ridiculously expensive. Millions a month for this sort of thing, I'd imagine.
I mean, as you say, it's designed for governments, big public utilities, all that sort of thing. So these people have got the money.
Yeah, Singapore is the pilot customer, or first government customer, according to the article. So the Singapore government's Smart Nation and Digital Government Group is the first government to run workloads on the cloud with the new deployment option. So I guess perhaps this is something they've designed specifically for Singapore, and then thought, maybe we can turn this into a product. And
well, like all good engineers, they've designed it with reusability in mind.
Absolutely.
I would like to see where this goes, right? Because from a UK perspective, AWS, as far as I know, is the UK government's first choice cloud provider for public cloud workloads. And yeah, GovCloud is a thing within AWS, and maybe they'd kind of look at using that. That's only in the US at the minute, but it stands to reason that other major economies would get their own one. Yes, I'm British and tooting my own horn. We're only the sixth biggest, yada, yada, yada. But, you know, fairly big economy, fairly big demand for cloud workloads. I'd like to think a UK GovCloud isn't far off. But maybe this is an answer to territories that don't need a full GovCloud, that don't need kind of the enormity of a GovCloud deployment, where they can get away with the subset of services that this is offering. So again, the article's saying it's mainly targeting VMs and Kubernetes. So it's EC2, EBS, ELB, that kind of thing. And given that governments don't tend to be massively forward-looking, probably the lack of serverless solutions isn't going to hurt. You know, they're probably not going to see it because they're still running VMs anyway.
Yeah. Cool. All right. Well, let's get our head out of the lofty heights of these clouds with big stats and big price tags, back down to something a little bit more realistic that we might be working on a day-to-day basis. So our next article is from the AWS Cloud Operations and Migrations blog. And the title is Set Up Memory Metrics for Amazon EC2 Instances Using AWS Systems Manager. So I think you were quite excited about this one, John. So tell us why.
I mean, excited is a strong term. The strong term.
I did use it with mild sarcasm.
Right. So I haven't done this for a little while. So let's do a few definitions, because I don't normally do this when we have a guest on, but let's do some definitions. So EC2 VMs. Systems Manager is a way of running things against your fleet, and I use fleet on purpose, of EC2s. This isn't the sort of product that's designed for a deployment of 1 or 2 or 3 servers. This is designed for dozens and dozens or hundreds and hundreds of servers in more of your traditional, we've moved out of our data center because we're a big oil and gas person and we've moved into AWS. So we're running hundreds or thousands of servers in AWS. So SSM, it's a loose collection of kind of logically affiliated tools, but in the fleet management subsection, it's got things like node management, patch management, compliance, all those kinds of things. We use Patch Manager to help our customers do patching, even though they've only got a couple of servers, because it will automate patching compared with the baseline, and that's, it's reasonably powerful and it's quite good. And we use node management because you have to use node management to do anything else within the fleet management spec, because you need to have the servers contactable via the service. So it's also kind of handy if you need to get on servers without using jump hosts or bastions, because again, you're talking to AWS through the console or through your CLI, and AWS is talking to the servers through their backbone. You're not kind of directly connected. So if you need to just hop on and run something, you don't have direct access, it's useful for that too, although it's quite hard for transferring files and things. Cool. Right. Why is this useful? So on your EC2s, you don't get memory metrics out of the box. You get CPU, and that's kind of about it. You get CPU and CPU related, so like things like load averages and stuff. But you don't get memory, you don't get disk, you don't get input output so much. These are all the things that you need access to the OS to be able to report on. So you have to install an agent to do that. Right. That's not a problem because it takes a minute to install an agent. But if you're doing it on 10 servers, that's painful, but it's a one-off. If you're doing it on 100 servers, it's unviable, or 1,000 servers, and it's just like, no, we're not doing this. So that's where SSM comes in. Now, SSM also uses an agent, but the agent is pre-installed on the vast majority of servers that you will have launched in AWS since about 2017. So unless you're running quite old workloads still, it's there already. So you go in, you make sure you've got your IAM permission set up correctly, and this is where it might get painful. But hopefully, if you've not done anything with IAM, the quick setup automation action will just kind of set it all up for you, and it's quite good. So if you don't already have an IAM role associated with your instance, it will just go and create the relevant one and associate it with all the instances that don't have IAM roles, so then they start magically talking to it. Great. So it's already pre-installed with minor changes in the console, which hopefully can be done for you. You can start using this. SSM will then be able to talk to every instance that it looks after, that's a managed instance, as it calls them. And then you can send commands, pretty arbitrary commands, to go and install the CloudWatch agent or your AV or anything in that regard automatically. And it will go off and it'll run them across your 1,000 servers for you. And it will just kind of tell you which ones have failed, which ones have passed, give you a nice report. And everyone likes a nice pie chart, right, of passed and failed. And it'll spit that out.
I love a pie chart, especially a 3D pie chart.
Well, I don't think this is 3D, but it is in color.
Yeah. Well, you could take the data out and create a 3D pie chart in another application, like PowerPoint.
But yeah, that's the short version, right? This is just giving you an example to install the CloudWatch metrics agent. You could do it for the logs agent. You could do it for any other kind of agent. You might have SIEM tooling. You might use another host metrics provider, Datadog, New Relic, whatever. And that's kind of useful because if you have the capacity to build a custom runbook or build a custom document, depending on how you're doing it, then you can just use it to install stuff. And that's great. And then what's even better is with a little bit of custom, it doesn't talk about this, but with a little bit of custom coding, you can work out every time a new instance is launched, run this document, and you write your document sensibly so it works out whether it needs to do anything. So every time you boot a new instance, it installs the things it needs to install. It installs its agents, it makes sure it's reporting, and so on and so on. Which covers off against the, I've made a new server and I forgot to install the AV. It did it for you. Brilliant.
Nice. Of course, it's an AWS post, so it's all cloud formation. Could you do the same in Terraform?
Yeah.
following the
Well,
principles?
Good question. I think so. Systems Manager is not brilliantly supported within CloudFormation and Terraform. Like I was looking at it for Patch Manager a little while ago, and there's been an open request on the Terraform repo for 10 months to do something with Systems Manager. And obviously CloudFormation's roadmap isn't public, but CloudFormation support isn't a requirement for a service. So it's a bit of a faff. So I think this is probably doable, but if it's not, it's not that hard. And if you're really feeling torturous, you can get Terraform to run CloudFormation.
Yeah, well, you could do that. Why not? Have you done that?
Have I got Terraform to run CloudFormation? No,
Yeah.
I value my sanity.
Cool. Okay, let's move on then to the next article we wanted to talk about this week. And this is off the back of the recent announcement that AWS will be charging for IPv4 addresses. And I think we spoke about this on a previous episode. I forget the charges now, but I think it works out about $3 or $4 a month per IPv4 address. And I did see, I think we shared another article in the newsletter about the value that that's going to bring to AWS based on the number of IPv4 addresses that they have, which is literally billions of dollars. But this article is more about how you cannot escape using IPv4 on AWS, even if you want to. So basically, if you want to use IPv4 on AWS, you're going to have to pay for it now. Of course, the first thought is, well, let's just move everything to IPv6. But I think there are some reasons why that is not feasible. That's the premise of the article. So what are your thoughts on this one, John?
It's an interesting one. I did in part pick it because the format of the article is very different to what we normally pick, and I just wanted to put that one out there because it's markdown style, technical blog, techie going on a rant. So it's my kind of article. He's not wrong. Generally, he's not wrong. So yeah, what's going to change? So I'm just going to read them verbatim.
I don't think. Do we actually know who he is? Because I don't think there's an author credited in the article, as far as I'm aware. But
I'm sure we can find it. Well, if we find it, we'll put it in the show notes. But so Elastic Load Balancers, they have to have an IPv4 address. They can optionally have an IPv6 on top because you can do dual stack, but you can't do IPv6 only, that's kind of the killer. Is as soon as you can do IPv6 only, that's brilliant because then you can do IPv6 to your load balancer, terminate IPv6 at your load balancer, and then if you're doing IPv4 internally, that's fine because you're using internal dedicated cider blocks. And that's the thing, go and look them up. There's 3 ranges that are earmarked for internal use only. So don't do like 30 dot because that's not internal, but 10 dot is great. So as soon as you can do that, then all of a sudden this becomes a lot cheaper because you don't have to sit there having IPv4 addresses for your load balancers. You can have IPv6 and kind of sack it off there. Great. EC2s and elastic IPs, yes, that's still a thing in IPv4, but I think part of this is to encourage you to stop using elastic IP addresses and do things like load balancers, because that way you're not talking to servers directly, you're talking to a load balancer, but that's not always appropriate for your workloads. You can usually get away with it though, so you'd have 1 rather than say 10, and then do things like host heading or do clever trickery with your DNS so that it says, I'm looking for this one and route that way. I'm looking for that one and route that way. So you can kind of work around that one, but appreciate that one. Fargate, yeah, fine. I think that'll come. That'll come in time. Global Accelerator, don't really care because you know if you need it, you need it. Site-to-site VPNs, again, that was a little bit annoying because if you need a VPN, you're going to have to pay for the IP. Great. RDS, 9 in 10 customers have public IP on RDS by accident. I don't know where he's got that number from. I suspect he's pulled it out of thin air. But from our experience, yes, public IPs on RDS by accident is quite common. It's not a thing that we see, infrequently. We see it semi-regularly. So your database is just going to start costing you another $4 a month. Now, for your database, you're probably not going to even notice, let alone care, because databases are expensive. But again, it's another thing that's making your database more expensive. And maybe it's encouraging you to, I don't know, make it private and do the work to do that. But if it's already public, that's a bit of a faff because you can't just go, oh, I'm private now. You have to rebuild the whole damn thing. And then manage NAT gateways. That one I think is quite rude from AWS's perspective. If that has to have an IPv4 and a managed NAT gateway is part of their recommended design and the well-architected framework, that's quite naughty, I think. Because they're saying, here's a thing, and it's magically costing you another $4 a month, and it's already really expensive anyway, because they're not cheap. So, yeah, that's the list of them. And I'm aware that I've ranted about things for a little minute, so I'm just going to prattle through very quickly. The takeaway from the article, and he's not wrong, again, is for most customers, nothing is going to change, just your bill's going to go up. Okay. So for the customers, this is designed to target, to encourage them to get off of IPv4 and onto IPv6. They're not going to care because the bill's already so high anyway that $4 a month per IP, they're just going to swallow it. They're either not going to notice or they're going to take it on the chin and go, our engineering time is too expensive to worry about this. We're just going to pay the bill because their engineering time is more expensive than their AWS bill is. Cool. If you think of like the confused.coms of the world, at their reInvent presentation, they said they had back in the day 5,500 load balancers. It's going to cost them more to move off of that than it is to worry about this. So they're just not going to worry about it. For our customer base, SMBs and smaller hobbyists, startups, that kind of thing, this is going to hurt because their bills are usually quite low already, particularly in the hobbyist space and the startup space. Their bill is usually pretty low to start with, so they're going to notice the $4 a month per IP. So larger customers that you kind of want to free up IP ranges, they're not going to care. The smaller people, they're only using a handful of them, they're going to feel the pain, and that just feels wrong.
And won't solve the overall shortage, even if they do choose to do something about it. Yeah.
Nope.
Well, there we go. I managed to find out that the author is German just by looking at his GitHub page, which is linked to from the blog. But I haven't managed to find out any more than that at the moment. But I'm sure with a bit of digging, we can find out who the author is. But I did quite like on his blog, on the about section, it says this blog focuses on IT infrastructure, usually in the context of AWS. Some other nerd rage posts may show up as well. This is quite amusing. So nerd rage, first time I've heard that. Those two words in the, next to one another in a sentence. But yeah, exactly. Nerd rage emoji. I'm sure you can knock one up, John, but there we are. So moving on from nerd rage, before I cause some, let's talk about the last article that we look, and it's not dark mode, so my face has lit up literally as I've switched a tab in my browser to read this article. It's not because I'm excited about it, it's just because there's lots of white on my screen now. So sorry if you're listening to this, you won't be able to see that. But the final article we want to talk about this week is about AWS cryptojacking. The title is AWS cryptojacking campaign abuses less used services to hide. So this, of course, is about services being used. Oh, the cat is waking up as well when I said cryptojacking. But cryptojacking, of course, is using AWS resources illicitly to generate cryptocurrency, I guess. And traditionally, that would be done on EC2s. But there's only so far you can illicitly use EC2s without having to go and ask for account limits to be increased. So the premise of the article is that it's better for these cryptojackers to use other services rather than EC2, I guess. So
that's
what
about the size of it.
Yeah.
First and foremost, it's called Amber Squid. I love the names on these things. It's just brilliant.
Yeah.
But yeah, that's about the size of it because EC2 has a soft limit on the number of. Who comes up with the names? No idea.
Yeah, I was going to say, is it the people who create it that give it the name, or is it the people that find it? Cyber security guys.
Yeah, I've no idea. I'll look into it. Don't know. But yeah, as you said in the intro, the TLDR on this is it's by using less commonly used services, so you're not hitting the obvious EC2 instance count soft limit, because that only gets to a certain point, then you have to increase things, and then by asking for approvals to increase things, then all of a sudden emails start being generated, you get found. So by doing things in places like Fargate or Code Build that are running containers, particularly in Code Build, because there's kind of no approvals for the amount of containers you can run, and more to the point, if you can get your Code Build process to just run and just mine crypto whilst it's allegedly building something, people aren't really going to notice because they either don't use Code Build, so they're not looking for it, and they don't analyze their bills well enough, or they're using it a bunch and it will just get lost in the weeds.
Fair enough.
Yeah, it's an interesting one, and there's a few other bits and pieces in there because it talks about code build, it talks about Fargate, which is a way of running containers without using servers. So again, unless you'll know it, unless you're being quite proactive at looking at your bills, which people generally aren't. I mean, we are because it's kind of part of the job. But if you're an SMB or a hobbyist or whatever, you're probably not checking it that closely. Going, okay, it's $10 this month. Oh, it's $20, whatever. You don't care because it's not a big number. And then all of a sudden it's $1,000 and oh geez, someone's kind of done something a bit naughty. So there's that. It also talks about SageMaker, which again, it uses containers. This kind of dovetails fairly well with Corey Quinn's 3 sets of articles on 17 ways to run containers. He did it 3 times because there's so many different ways of running containers in AWS. All of the slightly weird ones that you think that's not really meant to do that, that's where they're running these cryptojacking containers, because it's not really meant to do it, but it will do it. And then they've got access and they start proliferating themselves around the account, and you're a lot less likely to find it because it's not in the places you're looking. And when you do find it, you've got a lot more work to kind of start extracting them from everywhere, because even if you change all your keys, invalidate everything they've left deployed is still there. So you've then got to start traipsing through all of the services, trying to find where they've put things and get rid of them. Because honestly, you could just close your AWS account, but people aren't likely to do that, particularly if it's production.
So this last subheading is rather ominous. Cryptojackers can abuse any service with access to compute resources. What should people be doing to protect themselves from this?
I say obvious. It's the obvious account baselining stuff. It's turning on CloudTrail. It's turning on guard duty. It's looking in Security Hub. It's turning on Inspector. It's Macy as well to an extent, but that's more for PII and S3. And it's reading your bill, because ultimately the arbiter of everything that's running your account is your bill. So every line item in your bill needs to be investigated regularly. Maybe not every month, but yeah. Start with CloudTrail, start with guard duty, because they'll tell you when stuff starts running where they're not meant to be, where you're not normally doing things. And then, of course, you can do the other slightly more advanced trick of disabling services through IAM deny policies in like an SCP or what have you to regions that you don't use. So if you're not running things in Sao Paulo, turn it off. And yes, you can't turn the region off, but you can deploy a permissions boundary or whatever that says block everything that isn't a global service in Sao Paulo.
You know what I'm going to say now, don't you?
Sao Paulo?
Caching your data in Sao Paulo.
Caching your data in Sao Paulo.
Absolutely. Absolutely. But let's not go there, because we have, unfortunately, reached the end of our time for this week. So that was season 2, episode 34 of Logicast, the AWS News podcast brought to you by Logicata. Thank you very much for listening. As always, you can download the podcast from wherever you get your podcasts. So if you want to look at our faces while you listen to us, you can watch us on YouTube and other podcast video streaming platforms. So please don't forget to like and subscribe and share, and we'll be back with another episode of Logicast for you next week. Thank you. See you next time.